Hi folks, today I bring to you a VFD that uses both internal sides of the glass to support the phosphors and thus present two layers of the data, thus giving the feeling of the depth. I use 32 volts DC as VCC2 of SN75518 and 5 volts DC as VCC1 for logic voltage and also to feed the filaments. Please refer the SN75518 datasheet to see the correct voltage and the pinout, okay? Note that I'm using a cascade of two SN75518 to control the 45 pins of the VFD, a total of 11 grids and 34 segments. The concept of this VFD is a sample based on the cathode in the center and grids on both sides. The phosphor layers are deposited in each side of the glass to receive the electrons sent by the cathode. Another interesting feature is the color multiplexity. Since I had already present other VFD displays with multicolor, this one has the particularity of highlighting the green and the blue, achieving an unusual effect. I do not know the manufacturer of the stereo to which it belonged, but it seems to be a compact hi-fi sound system. I ran the code on the Arduino platform, as usual only uses pins 7, 8 and 9, has data in, clock and latch enable respectively. I tried to make the code as basic as possible and without using complicated libraries. You can see here the letters in the front glass and the blue in the rear glass. The total of the colors is four: green, red, blue and yellow. In the pins of the VFD, the first 11 pins in the left side belongs to the grids, and the first 4 grids belongs to the rear glass, and the remaining 7 pins belongs to the front glass, a total of 11 grids. The remaining 34 pins belongs to the segments, and I start from the right to the left to control the pins, and all these segments have functions in the rear glass and front glass. Okay. I try to show the connections I have made to the Arduino and breadboard, and the first thing I like to show is the Gnd from the Arduino go to the Gnd of the breadboard. The pin 789 is the orange data in, green clock, white is the latch enable, okay? Pin 9, 8 and 7. In the breadboard you can find the pin or the wire orange is connected here and go through the resistor of the 1K to the pin of data in is here below VCC pin. The green first, to follow the same order. The green go here, connect to a resistor of 1K and go to the pin of the clock. Okay, this pin clock go also to the second IC. The wire white or latch enable coming to the latch enable here and go to the latch enable of the first IC, and this pin have also a resistor of 10K to the VCC. Okay. This bar here is the Gnd Vcc, and you can see here the 5 volts connected in this point. And from this 5 volts I connect a wire through a diode to the filament, and the second pin of the filaments is connected to the Gnd with this wire brown. Okay. The VCC2, the 32 volts I'm using, is connected here and go to the VCC2 present here through a resistor of the 22 ohms only to protection. Okay. This IC have also here the wire coming from the VCC2. Okay. To the second IC, I catch here the serial out and go to the here, connect to the resistor to the data in of the second IC. Okay, and this is all the connections of the control is necessary to do to the work with this IC, and the remaining wires you see here is the pins from 1 to 32, and 1 to is not use all the pins, but maybe 16, I don't have a sure, I count here is a total of the 32 pins in the first and the remaining part to the second IC. Okay.